Where is everybody? Where is everybody?
We get extra credit for staying the last hour.
You know what? I could take an attendance audit. You guys will get your points for being here, and then the people who aren't here will miss out on their points. Okay? So we can do that. That's no problem. Sorry, I forgot your name. Can I get a sheet of notebook paper for you? Okay. This is what we'll do. All right. Okay, so what's going to happen is a piece of paper is going to come around, and just print your name nice and legibly. Put your number, just number it 1, 2, 3. Okay. Once one side fills up, just flip it over to the back. Keep going. Okay. I'm going to take a count of how many students are here. Do not sign in your friends. Don't, you know, if you have a friend who's absent, don't sign them in, because if the numbers don't match, this will not count. Okay. So I'm going to just count very quickly, and the number of names on my paper at the end should match how many students are here. Okay. Yeah, we're missing a lot of students. I don't know what to say. You know. What's that? Attendance, the audits account for 5% of your total grade. Okay, so there's a couple. It's not an extra thing. It's just you're not going to be penalized. All right, for being here. Okay. And then you know what? There's going to be students who fail the midterm. That's just.
Do you fail the class?
Huh?
Do you fail the midterm? Or is there like no possibility of getting an A?
It depends how poorly you do on the midterm. If you get a 0% on the midterm or 10% on the midterm, there is no possibility of getting an A. That's for certain. And then it's also very unlikely that someone will pass the class. That's the case. But no, there's going to be students who fail, and I'm going to check their names against my attendance list, and I'm going to say, well, the reason why you did poorly on these questions are because you were not here. Yes. Question. There's no curving, okay? I found historically I haven't needed to curve. The students who do all their work and come to class, everyone does. They do fine, okay? The students who I'm expecting to do poorly generally end up doing poorly. Sometimes that happens. It breaks my heart, okay?
Yeah, it breaks my heart.
I often find those cases are often students who do not have the necessary prerequisites for the class, okay? All right, anyway. We shall we'll carry on. Okay, so the normal model. We learned how to look up z-scores in the normal table. Okay, we can, if you remember stuff from chapter 3 about how to find a z-score, we can combine those things into using the normal model. Okay, you guys remember how to find a z-score?
Yeah.
Okay, what is a z-score? A z-score is the number of standard deviations we are from the mean. So how do we find a z-score? We say z is equal to the x that we are looking for minus the mean. Okay, that gives us the distance from the mean, but that's not what we're interested in. We want to know how many standard deviations that is, so we divide that by the standard deviation. If we use symbols, we would do x minus mu divided by sigma. This gives us our z-score. Okay, so we are going to combine this knowledge of finding a z-score, which we are already familiar with, right, with using the z-table. So let's try a problem, okay? So let's say the heights of men in the United States follow a normal model. Okay. The mean is 70 inches, or 5'10", and the standard deviation, for simplicity, we will say is 3 inches. Okay. I'm going to say what percentage of men are shorter than 5'8" inches, 68 inches. Okay. So the average height is 70%. 70 inches, not 70%, sorry. So that means 50% of males are taller than 70 inches, 50% of males are shorter than 70 inches, according to this. And we are asking what percentage of men are shorter than 68 inches, 5'8". So let's find our z-score. What is our z-score? Z-score would be equal to 68 minus 70 divided by 3. Just pause here and see if anyone has any questions. Okay, so then this gives me negative, and I'm going to round to 2 decimal places. For z-scores, we round to 2 decimal places, and I get negative 0.67. So I generally recommend keeping 3 or 4 decimals, but for z-scores, round to 2. Okay. And when I'm saying what percentage of men are shorter than 5'8" or 68 inches, I'm essentially asking what is the area to the left of that. Okay? So now I'm no longer asking what's the area to the left of 68 inches. I still am, but I've turned it into a z-score. So I'm saying what's the area to the left of z equals negative 0.67. What's our answer? So you'll have to look in your table and find the answer. I need my table actually myself. And our answer is 0.2514. Is that okay? Okay, because of time constraints, I'm going to teach the next topic, and then I'm going to give you a couple practice problems that you can do. practice problem I put on Facebook helpful or?
Oh, yeah.
Yeah, okay. I felt it was there. Okay. Alright. So I'm going to do a reverse question, okay? Basically, over here I said what percentage of men are shorter than 68 inches? And we said the answer was 25.2514. Okay? The next question I ask is going to be in this format. It's going to be, I'm going to say 25.14% of men are shorter than this height. What is that height? And you would tell me 68 inches, right? We just figured this out, right? We said what percentage of men are shorter than 68 inches? And we said 25.14% or 0.2514. So now I'm going to flip the question around and it's going to be kind of like this. It's going to say, I'm going to say 0.2514 or 25.14% of men are shorter than this height. What is that height? And you tell me 68 inches. Does that make sense? Okay? Except I'm not going to ask that question. I'm going to say, I'll say 70% of men are shorter than blank, or not blank. Okay, what is this height? Another way, okay, does this question make sense?
Yes.
Okay. Maybe some of us know how to answer this, maybe some of us don't. That's okay. We'll go over how to do this together. But I want to say this same question can be rephrased in another way, okay? And we could say the 70th percentile. Sorry. 70th percentile of men's height is blank, okay? So when we say 70% of men are shorter than this, we are essentially saying the 70th percentile. So are you guys familiar with percentiles? You guys are breaking my heart. You guys are breaking my heart. Where have we heard percentiles before? Okay, the SAT. How about week 1 of this class?
Yeah.
When we were talking about quartiles, right? We said the first quartile is the 25th percentile, meaning 25% is less. You guys remember this?
Yes, sir. I'm sorry.
I'm going to go home and cry.
Please don't do that.
Yeah, it's alright. It's alright. My life is hard, you know? Okay. So we're asking 70% of men are shorter than this height. Okay, well, how do we do this? Alright, this time, if we draw our picture, what we don't know is we don't know where I'm drawing basically my cutoff line. But what do I know? I know that how much is to the left of this cutoff line? 70%. So I'm going to write 0.7000. Okay? So what I'm going to do is in the table, I'm going to look for the area that's closest to 70%. It won't be exactly 70%. But it's going to be the number that's closest to that. And what is the number that I have?
0.7019.
Okay, so I see two candidate numbers. I see 0.6985 and I have 0.7019. Okay?
6985.
This one is actually closest. Okay? This one is a little bit further away. This one's the closest. So I'm going to use this number. This is the closest number I have to 70%. And what number gives me 0.6985? 0.52. It's in the row 0.5 and the column 0.02. So the z-score that gives 70% is 0.52.
Okay. So 678 times 0.52.
Okay. I'll give you guys a second to catch up. Make sure we understand this.
Yeah.
So, this is the approximate z-score that gives 70%.
Yeah. Approximate z-score, we'll just say the z-score, okay? We're not going to get any more precise than this. So the z-score we're going to use is 0.52, okay? So z-score 0.52 tells us what? That we are how many standard deviations away from the mean?
5.52.
We are 0.52 standard deviations away from the mean, okay? Maybe that was too easy of a question, or maybe...
Yeah, it is.
Okay. So z-score says we are 0.52 standard deviations away from the mean. What is my mean? 70 inches. What's my standard deviation? 3 inches. So what is the height that's 0.52 standard deviations away from the mean? Can we answer this?
Yeah.
Yeah? Okay. Well, tell me.
69 inches.
No? That's going the opposite way.
I mean, 71.5.
71.56, okay?
56.
Now how did I get that?
Divided.
All right,
Multiply 3 by.
Let's do this, all right? So this is my equation, right? Z is equal to x minus mu divided by sigma. I'm going to plug in the numbers that I have. So what do I have? I have z. Z is 0.52. Do I have x?
No.
No. I'm going to leave x as x. Do I have mu?
Minus
Okay, that's 70. And do I have sigma?
3.
3. Do we know how to solve for x? I sure hope so. Okay, this is where I say make sure you know your algebra. X is equal to 71.56.
Yeah, look, just that one's easy. I would probably fuck up to that one.
Is that okay?
Yeah, oh, so you're laughing. It's obviously not you.
Yes. Good.
And the only thing that I don't understand
Uh-huh.
is, so 70% of men are shorter than, right?
Then
So
71.
then us. Okay. Why isn't it though? Was this using the information above? From
yeah,
above?
it's using the same problem. Heights
Yeah.
of men in the United States follow the normal model with mean 70 and standard deviation 3.
Right. So why isn't it just x minus 70 over 3 equals 0.70?
Because the z-score is not 0.70. The z-score is 0.52.
So that 0.67 from before, that was a z-score? Oh yeah. That right there.
Yeah, 0.67 is the z-score.
Oh, I thought it was a percentage.
Okay, it's not a percentage. Well, it can't be a percentage because it's a negative. Okay? Percentages always have to be between 0 and 1.
Right.
So it can't, or 0 and 100%. It can't be a percentage. Is that okay? Smile? Alright, okay. Okay, and I'm going to do one more example where I'm leading you through, and then I'm going to put a bunch of examples up on the board. You can write them down, and I'll give you the answer separate for you to do as practice problems between now and next week, because you'll see a bunch of these types of problems on the midterm. Not a bunch, but a few, okay? Alright, so So we're still using the same, okay, we're going to say heights of men come from normal model. The mean is equal to 70, the standard deviation is equal to 3, okay? I'm going to ask, what percent of men are between 68 inches and 72 inches? Now let's do 70,
This is a whole new example, not
71 inches. Okay. We're still using the normal model for men with a mean of 70 and standard deviation of 3, but this is an entirely new problem. What percentage of men are between 68 inches and 71 inches? It's a new question. So what percentage of men are between 5'8" and 5'11"? That's the question I'm asking. So let's draw a picture, okay? The mean goes in the middle. So what goes in the middle? 70.
70.
Yeah, that's okay. If for the standard normal, the mean is 0. That's correct. But if we're talking about the heights of men, 70 goes in the middle. I'm asking how much are between 68 and 70. So I'm going to draw a line over here to represent 68, okay? It doesn't really matter where you put 68 as long as it's to the left of 70. And 71 has to go to the right of 70. Is that okay? So I have this, okay? Because on one of the short answer problems, you're going to have to draw a picture. Kind of like this. And just make sure that smaller numbers go to the left and larger numbers go to the right, okay? Because sometimes I will see people do something like this. They put like 71 here and then they'll put 70 over here and 68 over here. Okay, if you do this, I'm going to get very upset. Right? Because there's no universe where 71 is bigger than 68 but smaller than 70. Okay, that's... It doesn't, it's just not possible. Okay? It's impossible. Okay, so we want to know how much is in between here. Okay? So this is how I'm going to do it. I want to get this middle portion, and I'm going to say, first I'm going to find everything to the left of 71. Do I know how to do that? Yes, I do. Okay? And then I'm going to find everything to the left of 68. Okay? And so if I take this area and I subtract off this area, I will be left with what's in between. Does that visually make sense to you guys? Okay, good. So I'm going to find this and then subtract this. Okay, but I also have to find this first, right? So find this, and subtract this from this. Okay. So let's do area to the left of 71. So I find my z-score. Z is equal to 71 minus the mean of 70 divided by 3, the standard deviation, and I get a z-score of 0.33. Area to the left of z equals 0.33. I look this up in the table. And we get 0.6293. I'm going to just slide this up. find area to the left of 68. Okay, hint, we've already done this before. 68 minus 70 divided by 3. Yes, question? No. We are looking for the area to the left of 68 inches, okay? No. We're finding, so if this is 68, we're still finding the area to the left. So we're finding the area to the left of 71, and we're finding the area to the left of 68. Okay? And we're taking the difference between the two. Okay. Did that work out okay? Alright. No, go ahead, write it down, okay? We're gonna move on to the next topic. I'm gonna teach you those things. And then I'm gonna put a bunch of example problems up on the board for you to copy down into your notes, for you to work through on your own time as you study this week for the midterm, okay? And I'm also gonna include the answers, but put the answers on a separate page so you can work through the problems on your own. Yeah, I'll get up to it. Okay? Alright, so I'm going to just go ahead and slide this up and start working on our next topic. Okay? So we're going to learn the binomial distribution. Okay? And this is just going to be the light version, alright? We're not going to fully learn the entire binomial distribution.
So it's like
We're just
diet
gonna,
binomial distribution?
huh?
It's like diet.
Diet, yeah. It's,
Which aspect became like a brain cancer?
Alright. I'm just telling you this because basically you're going to use a table to get your answers. Okay? If in a more difficult statistics class, you would have to learn how to calculate these manually. Okay? In our class, we're just going to use a table. So you just need to learn how to use the table. Okay? When you use the table, or whenever you're dealing with a binomial distribution, there's three elements that you need to identify. Okay, you need to identify n, you need to identify p, and you need to identify x. Okay, these are the three elements you must identify. N is the number of trials. And I'll explain all of this in a moment, okay? Okay. P is the probability of a quote-unquote success. And X is how many quote-unquote successes we are interested in. So those are the three pieces you need to identify for any binomial distribution problem. Okay, so first off, what is the binomial distribution? Okay, it's a random variable, this time discrete. We are looking at the number of successes, quote-unquote successes. It's an arbitrary label. Basically, we are doing a random event or random experiment multiple times. Every time I do an experiment, there's only two outcomes: a success or a failure. These are arbitrary labels, okay? So the experiment could be, I flip a coin and I label tails success and heads failure. Okay, and I can flip a coin 10 times, and in that case n would be 10. P is the probability of success, so what's the probability it lands on tails? 0.5. And I could say x is how many successes we're interested in. Maybe we're interested in 4 successes. So the in that instance, I'm saying if I flip a coin 10 times, what's the probability the coin lands tails exactly 4 times? That's a binomial problem. It could be something else. It could be, every now and then McDonald's has Monopoly, right? And then they say something like 1 in 4 wins. Okay, and you're like, oh yeah, I'm gonna buy the Big Mac combo super size or whatever. Oh, they don't do super size, large size now. Okay? So they say 1 in 4, okay? So maybe you buy a whole bunch of food and you get 8 game pieces, okay? So what we're saying is, if I play the game 8 times, the probability I win is 1 in 4, so probability is 0.25. You know, what's the probability I win once? Okay, so in that case, number of trials is 8, probability of success is 0.25, and I'm interested in winning once. Or I could ask, what's the probability I win twice? Or I could say, what's the probability that even after playing the game 8 times, I don't win? So success would be, x would be 0 in that case. Do these examples make sense? Okay, these are binomial distributions. Okay, so the defining features, okay, is we repeat a random experiment times. Okay, random experiment could be flipping a coin. It could be playing a game. Okay, or it could be shooting a basketball. Okay, each trial of the experiment can result in either success or quote failure. Now, we associate positive and negative feelings with success and failure, but these are just arbitrary labels. It's just saying this happened or it didn't happen. Okay, so sometimes we talk about binomial distributions and the birthing of children. Okay, and maybe we're asking how many boys, or what's the probability that 5 boys will be born? Okay, well in that case you have to label one of the genders a success and the other gender of failure, okay? And, you know, I leave it up to you which way how you want to label it, but these are just arbitrary labels, meaning either this happened or it didn't, okay? So each trial of the experiment can result in either a success or a failure, okay? Each trial has the probability P of a success. Okay? And we want to know after n trials, what is the probability of x successes? So this is a binomial distribution problem. So let me just slide this up while you guys still write that. And let me put down some examples. Okay. So example 1. I flip a coin 10 times. Okay. The probability that the coin lands tails equals 0.5. What is the probability that in 10 flips it lands tails 4 times? Alright, so in this case, what is n, what is p, and what is x?
And it's 10.
N is 10, p is
Is
0.5, and x is
4.
4. Great. Okay, leave some space here. We're going to look up the answer to this question in the table in a moment. Example 2. I buy a bunch of McDonald's to play Monopoly. I love McDonald's, by the way. It's like, huh? I think I've eaten everything on the McDonald's menu. No regrets. No regrets. Not in one sitting, of course. I buy a bunch of McDonald's to play Monopoly. I play the game 8 times.
If you ever want us to bring McDonald's, let me know.
Yeah, right.
And I will bring you McDonald's supply.
Okay. I cannot accept gifts
What do you order?
unless I be accused of bribery. All right.
No.
I play the game 8 times. Okay, they say the probability of winning is 1 in 4. Okay. What is the probability I win 1 or 2 times? Okay. N is, P is X. Okay. So I play the game 8 times. The probability of winning is 1 in 4. What's the probability I win 1 or 2 times? Oh, you know what? I can't do 1 in 4, okay? Sorry, I lied. Let's do 1 in 5, because our table doesn't do 1 in 4, I apologize, okay? So we'll say 1 in 5.
What's the other?
Huh?
None.
Yeah, don't worry about it. Okay, so N is 8, P if it's 1 and 5 is
Point two.
0.2, and x is
1 or 2.
1 or 2. Okay? Alright, how are we feeling? Identifying n, p, and x. Okay. The hard part on the midterm is I'm going to have a problem written out kind of like this. But I'm not going to say, here we're doing binomial problem. Okay? It's going to be written like this. And from reading this, you got to say, oh, this sounds like a binomial problem. Let's figure out n, p, and x. Okay? But I'm not going to be like, binomial alert. Okay? It's just going to be mixed in with everything else, and you got to read it and figure it out. All right? Okay, so this is what we do. Take out your binomial table.
Which one is the binomial table?
It's table 3. It says binomial probabilities. Okay? So first we're going to do example 1 with n equals 10. P is 0.5 and x is 4. Okay? You're going to go on page A5 in the leftmost column. You see a 9 and then a 10, 11, and a 12. Okay? And then you see the 10 is lined up under the n.
Yes.
Okay, so you're going to go to that section. And then, so when you use the table, it actually makes sense to go n, x, and then p. Okay? So you go to right there for 10 under n, and then you go to x equal to 4. So within that section of 10, you go to x is 4. And then you go to the column where p is 0.5. Okay? And so the answer is 0.205. So you go to so you find the section n is 10, then you go to the row x is 4, and then you go to the column for 0.5. And we get our answer to be 0.205. Yeah.
Okay, so you know how like you were like x equals 4.
Uh-huh.
What does 0.205 equal exactly?
This is the probability that in 10 flips, it lands tails 4 times. It's the answer to the question. So right, if I flip a coin 10 times, what can happen? The coin can land tails 3 times, it can land tails 4 times, it can land tails 5 times or 6 times or whatever. I don't know what's going to happen. What's the probability that it's going to land tails exactly 4 times out of 10? The answer is 0.205. Yeah.
Wait, didn't we just do that on this past quiz and just do 0.5 times 0.5 times 0.5 times 0.5?
We did something very similar, okay? And the binomial is based off of those exact concepts, okay? And in a more advanced statistics class or just a harder one, you would have to do the 0.5 multiplied and all of that stuff, okay? But things get a little bit complicated because when I say I flip a coin 10 times and it lands tails 4 times, I don't know if it's the first 4 flips that land tails or the middle 4 or the first 2 and the last 2. There's all sorts of different ways. I could flip a coin 10 times and it lands tails 4 times, okay? And this binomial table takes into account all of those different ways, okay? So it's a little different, but getting 0.205. Okay, so here I have x is 1 or 2, so I'm going to have 2 different answers, and I'm going to combine those 2 answers, okay? So what is it for x equals 1, and what is it for x equals 2? Go ahead and find those.
Do 6 and 2 down
Okay. Okay, so when I look up n is equal to 8, p is 0.2, and x is 1, or x is 2. For x is 1, I get 0.336, and for x is 2, I get 0.294. So to get what's the probability of A or B, what do I do? I add them together. These are actually mutually exclusive, okay? Because if I play the game 8 times, I can't win at the same time once and at the same time twice. I either win once or I win twice. Okay? So I add these two together, using our rules that we learned last week. So I do 0.336 plus 0.294, and I get 0.730. 630. Sorry. Just kidding. Uh-oh. How embarrassing. I'm gonna really go home and cry and take my head in shame. Okay.
Tell your wife bye.
Huh?
And then tell your wife bye McDonald's make you happy.
Yeah. We almost went to McDonald's earlier today. Huh? I wouldn't say it's an addiction. I could quit any time I wanted to, right?
Can I please ring you like a Big Mac? I want to do it just for the sake of doing
I don't know how to answer that question, okay?
If there's one on your desk, will you just eat it?
Alright, so you just want to see me eat a Big Mac?
Not even that. I don't care if you just throw it away. I just want to eat it.
If I was anyone else, I'd probably be offended, but whatever. I don't care. Alright. Okay, so right now I'm going to put down a bunch of example problems.
Those weren't example problems.
Well, they are example problems, but these are going to be example problems where I don't work out the answer in front of you. Okay? You work these out on your own. I'll put the answers over there. Maybe I'll put a bit of the work here. Okay? This is to help you guys, all right, as you study.
What was the?
What's going on?
What was it that you said before about like you're gonna have to figure that part on your own? Like I won't point it out there, like alert, whatever.
Oh, what as you're doing problems, I'm not going to say this is a normal model problem. Use your normal model stuff. I'm not going to say this is a binomial problem. Do your binomial stuff. Okay? I'm just going to have problems written out. You're going to have to figure this out. Okay. With that said, a problem might be written like this. Okay? So. The weight of, I don't know, dogs, we'll say Labradors, follows the normal model. Mean is 65 pounds, and the standard deviation
choose 87%.
Yeah, it's not quite 90%,
Yeah, it's around
but
87.
your table doesn't do 87, alright?
Oh,
So,
okay.
so I just gotta go with the
Alright.
nearest one, okay? I know, I'm being generous.
Yeah, good for him. All pro point guard. He should have been over.
I mean, that wasn't the game. They need two players to get the match. Like, they're not really easy. Police are tied. National police are tied.
CP3.
Okay, I'll give you guys a chance to write that down. Did everyone write down these questions? Okay, you're still writing these questions down? I'm writing them myself. Okay, okay. Huh? So CP3 is Chris Paul, okay? Because he wears the number 3. He's in the State Farm commercials.
With his twin brother.
With his twin brother Cliff Paul. He's like the number 4 fantasy basketball player. Okay, I'm gonna start writing the answers, okay, over here. If you're gonna copy the answers down, I would say use a different sheet of paper, okay?
Bless you.
Can I erase, start erasing this stuff over here?
No, number 2.
No?
Oh, yeah, yes. I thought
Okay.
Part B?
Yeah, this is the answer to part B, sorry.
I mean, I can't say. Wait, so I'm sorry, the first 2A was asking what makes all 7?
Yeah.
Sorry.
Is this the long version or the short version?
This is this is it, okay? I'm not sure what this is.
Can I get your number?
I'm sorry, if you gotta go, you can go, okay? I'm just giving you the answers, okay? So this is,
What about this?
It's gonna be online. Recording it.
No, but I can't see that. You will?
have a good night, you guys. Okay, that's the answers. Those are the answers. Yay. Alright, good luck you guys as you study. I'll see you guys